Hey guys, let's build a Viking sword. This sword was actually a present from a groomsman to a groom. And if you like these, don't forget to hit like and subscribe. All right, let's get started. And I can tell it's going to be a great day. I forgot to take the tongs out and they froze in the pail. We're going to start off with this bar of 5160. We'll mark it up. We'll draw a center line down the middle and get prepared to actually grind the fuller. I found this cool website to help me actually calculate the size of fuller to put on my blades. It shows me the width of an arc. I did a whole video on this, so I'll put the link in the description if you do want to use this website. It's got all kinds of formulas and calculators that you can use in your blade making. Grinding the fuller is really just taking my 2-inch wheel and making sure I keep it centered in the blade on that line. I do that by altering the angle with which I hold the steel. It gets easier once I get deeper. It starts to create a track that I can stay in. Measure the depth of your fuller. You could use a micrometer if you've got one. I simply lay a bar in the bottom of the groove and then measure the height by taking the difference between the bottom and the top. With the fuller in the blade now, we're going to actually taper the blade. We're going to be 1.5 inches at the top of the fuller and a full 2 inches at the back, and then we'll grind in the tip as well. One of the things I really like about my grinder is its ability to go horizontal. This helps me create nice straight lines without any jagged edges. It also really helps when it comes to grinding in bevels. I have a nice flat surface I can grind against. And after a bit of grinding, what we end up with is a blade that's getting close to ready for heat treat. The last part we have to do, we have to actually put a tang, and I'm going to leave a nice rounded corner just to avoid any stress points. Lastly, we're going to grind in a little bit of a taper on the blade. My end goal is a 1/4 inch at the base and maybe 1/8 of an inch at the tip. To get ready for heat treat, what I'm going to do is coat everything with no scale and then off to the kiln. First step is to normalize the blade. We'll start off with 1600 degrees for about 15 minutes. Then we'll let it air cool, then 15, then 14. We'll quench this at 1525 degrees. I've actually got the kiln set just a touch warmer, just so that when it cools off for that slow transition over to the tank, I'm actually at about 1525 when it goes in. 30 seconds in the oil, and then over to the straightening jig. I did a little video on how I keep my straightening jig in the vise. It's just a couple of magnets I use, but it really keeps it there solid. And we'll let it cool and then get ready to take it over to the grinder to finish up the grinding. As you saw, I have a little bit of a problem with my water freezing. So one of the ways I like to cool off the snow while I'm working, you can actually see my breath. It's a little cool in the shop right now. I go over to the snowbank. Works really good, keeps the blade cold. It can even put a thin layer of ice on the blade so that when you go back to grinding, it still keeps it cool. And at the end, we have a blade that's heat treated and now ready for the guard and handle. I'm going to use a piece of mild steel. I'll go over to the milling machine and I'll mill a slot. I'm still going to have to file it. I'm not good enough to do these to spec yet. I really tip my hat to the machinist that can create a slot exactly to a dimension. I can't. When fitting up the guard, I take a 2-pronged approach. I make the hole a little bit bigger, but I can also make the tang a little bit smaller. So here I am just trimming up the tang so that it fits a little nicer. With the fit up pretty close, I'll use a Dremel and these diamond bit wheels to actually put in the round part at the front of the guard and make sure that I get a nice tight fit up. Next, we've got to make the spacers for the front and the back of the handle. That's going to be some 1/4 inch steel along with 2 pieces of black micarta. I'll take this piece of stabilized birch and we'll take it over to the milling machine again. And I'm actually going to mill as deep as I can. This will keep the hole at least relatively straight. I'll have to drill through the rest of it and file it out. But this allows me to actually keep the hole going a little bit straight. It's almost like using a little bit of a center drill. My drill bit isn't quite long enough, so I'll flip it over using the same side as a reference against my vise to drill that last little bit. Lines up pretty good, but I've really only got a 1/4 inch or so to go through. And then it's simply filing out that hole to get a nice snug fit. As you can see, I got a ways to go. Time for a test fit up, and then we'll start shaping the handle. To put in the alignment pins, what I want to do is actually just put a drop of CA glue on all the parts. But I have a problem in the cold. My CA glue is just about near frozen, and it's this goopy mess. Took a while for it to actually dry up, but I actually had to dab inside. It wouldn't pour anymore. We'll drill some holes for some alignment pins. I simply use finishing nails. I cut the top off, and I have this nice steel pin with a centered point on one end. We'll use this piece of ready rod to hold the whole handle assembly together while we shape it. With the alignment pins in place, I don't have to worry about it not fitting up properly. I find it interesting when I'm shaping handles, I still use the square, octagon, round method for actually making my handles nice and smooth. Um, it's just like when you're forging. And with a nice round handle, we'll do a test fit up, and it's starting to look pretty good. To hold the pommel on, I'm going to use this 1024 ready rod. We'll cut a slot in the tang and use the TIG welder to weld it in place. I used to use a MIG welder, but since I got the TIG welder, I'm sure finding the TIG welder is a nice tool to have in a knife shop. And I'm still learning, and like most good welders, I need a grinder and paint to make my welds look good. We'll use this block of mild steel for the pommel. We'll start off by scribing in a center line, and then we'll go drill a hole for the pommel nut. I drilled a small hole just the size of the 1024 ready rod, and then I'm drilling a larger 1/4 inch hole that I only want to go about 3/4 away through the pommel. That way my nut will press the pommel up against the handle. To create the pommel nut, first step is to drill a hole that we're going to use to tighten up the pommel nut, and then we're actually going to drill the hole and thread it before we start shaping the nut itself. I won't lie, I actually had to do this twice because I broke a tap off when I was tapping the first hole. But once we can get the ready rod threaded in, it's time to actually start milling down the shaft so that it actually fits in that hole we drilled in the pommel. I know the machinists would use calipers and simply turn this down to a spec. I just do test fits until I get a nice snug fit, taking off a couple thou each pass. A good fit up, we'll flip it around in the lathe. we'll cut it off and we'll actually turn it down and grind in a nice little groove using a file. I'd like to someday learn how to actually machine these in, but for right now this seems to work. And with our pommel nut now making a nice snug fit, we'll actually add a little bit of shape to the pommel, and then we'll get ready to start hand sanding. I'll save you the pain of watching me hand sand the flats of the blade, but the fuller is always the thing that drives me crazy. So what I did is I actually created this little tool. It's nothing more than a block of hardwood. I put a threaded rod down the middle of it, and then I simply use this Rhino wet sandpaper, stick it in the groove, stick it to the hardwood, and then chuck it up in a drill to actually sand the center of the groove. With everything sanded up, it's time to go over to the laser and do a couple of test etches on a piece of scrap steel. We want to put a coat of arms on the pommel, some runes down the length of the blade, and we want to checker the handle so that it has a little bit more grip to it. I'm using a 20-watt fiber laser. It's a Laser Pecker 5. If I had to buy a laser again, I might try and go up in wattage a little bit. This actually is sped up quite a bit. It takes a while to put these in, but they do look nice in the end. Don't forget, after lasering it into the steel, it's still a little bit hot when you pick it up. So don't do like I just did. I love how this pommel nut turned out. I actually etched a Celtic knot on the top of the pommel. And does it ever look nice? Now, we add some magic to the sword by invoking the gods and the elements. We're going to add some texture to the handle by burning in a checker pattern just to give it a little bit more grip. We've got a smooth piece of wood and I want an actual positive grip on the handle. And now it's time to assemble the whole sword, and this is what we get. That looks nice. If you like these, please like, comment, subscribe, ask any questions you want. Stay tuned for the next one. I'll put all of the links in the description, and we'll see you for the next build.
Blacksmith, blacksmith, forge me a blade of the strongest steel, that when I strike my enemies, their wounds may never heal. Blacksmith, blacksmith of your blade, legends there shall rise, for the blade that you will forge for me will deliver us from the night, the night.